Welcome to FMSP Online Revision. This session is for AQA M1. We're doing question 2 from June 2010 and it's about forces and Newton's laws of motion. So just having a quick look at the question first of all. So we've got a block of mass 10 kilograms resting on a rough horizontal surface and it's acted upon by a horizontal force P, which has P newtons is applied. And we're told that the coefficient of friction between the block and the surface is 0.5. So we've asked to draw and label a diagram to show all the forces acting on the block, to calculate the magnitude of the normal reaction force acting on the block, find the maximum possible magnitude of the friction force between the block and the surface, and then given that P equals 30, we've got to state the magnitude of the friction force acting. And lastly, part C, given that P equals 80, we're asked to find the acceleration of the block. So if we start then, just remember we've been told that the frictional force, the coefficient of friction is 0.5. We'll remind ourselves that friction is always less than or equal to mu r, where r is this normal contact force. So when we're drawing our diagram, remember that the weight of this block is going to act downwards and the weight is going to be 10g, and opposing that there will be this reaction force, which we'll use the letter R for the reaction force. Assuming that we're pulling it in this direction, then of course the frictional force will oppose that, so we'll act in that direction. So we need to mark those four forces on. In the first part of B, we're asked to calculate the magnitude of the normal reaction force. So effectively what we're doing there is we're resolving vertically. So we've got this upward force of R, and that is equal to 10g, the weight. G is 9.8, so that's 98 newtons. And then in part 2, so we know that the frictional force is less than or equal to mu r, but the maximum possible value that it can have is when it's equal to mu r. And so we now know what mu is, because that was given, and we know that the reaction force is 98, so it's 0.5 times 98, which is 49 newtons. So that's the maximum value that friction can take. But in part 3, it says, given that P equals 30, state the magnitude of the friction force. Now if P is 30, then friction only is only as big as it needs to be to oppose motion. So that means in this case the frictional force will also just be 30. There's no movement. So the frictional force will only be as large as it needs to be. And then in part C, it says, given that P is equal to 80, now bear in mind that we have now got acceleration, so we've now got a resultant force. We've just worked out that the maximum value of friction, if we remember, the maximum value we had was 49 newtons. Now when it's accelerating, this maximum value will act upon the block. So using F equals ma, so Newton's laws, then the resultant force is going to be the 80 minus the frictional force of 49, and that is going to be equal to the mass, which was 10, times the acceleration. So just looking at the diagram that we have over here, so this was 80 and this is 49. So our resultant force is just 31. So 31 equals 10a, so a is equal to 3.1 meters per second squared. So just going back, each of the marks in this particular part here were just sort of statement marks. So you got a B mark there for drawing a correct diagram, and you got a mark there, and a B mark there, and a B mark here. So 4 in total there. And then when you came to this particular bit, there was a bit of more method involved. So there was a method mark and an accuracy mark for using Newton's laws, and is the method mark, and then for totally accurately putting in the 80 minus 49 equals 10a, there was an accuracy mark, and then another accuracy mark for getting 3.1 meters per second squared. So if you do want any more online revision videos, then go to the Further Maths Support Programme website and follow the link.